Welcome to the third session under Unit 1, Aromaticity and the Haeckel pi electron rule. At the end of this session, you should be able to state the criteria necessary for aromaticity, use the Haeckel's rule to identify aromatic compounds, and then also give examples of aromatic compounds. Now, based on what we just talked about in the molecular orbital theory in session 2, now an aromatic compound or aromatic species is identified by planar ring with a delocalized pi system. Delocalized pi system meaning that the pi electrons in the aromatic system can alternate, leading to conjugation and then of course resonance. So basically, for a compound to be referred to as an aromatic compound, it has to meet these following criteria. It has to be planar, has to be cyclic, of course, it has to be a cyclic ring, and then of course contain the delocalized pi electrons, which lead to conjugation and resonance. So we can say that that is what we use to these three things, criteria are what we use in identify a compound as aromatic or not. However, not all rings that are drawn with alternating single bonds and double bonds are referred to as aromatic compound. A typical example is cyclobutadiene. Now, cyclobutadiene is here. It's planar, alright. It has the conjugated pi system, alright, and it's cyclic. However, it is not considered as an aromatic compound because of the Haeckel's rule. Now, the Haeckel's rule is 4n plus 2 pi electron rule that is used to determine aromaticity. So it's also another criteria which is very key in determining the aromaticity of a compound, because although this particular structure, cyclobutadiene, is cyclic, is planar, is conjugated, because it's not obeying the Haeckel's rule, it fails to become an aromatic compound. And the evidence is seen in the chemical reaction that cyclobutadiene undergoes. It actually undergoes addition reaction and not substitution reaction, as we all know for benzene structures. So the next slide we'll be looking at the Haeckel's rule. Now the Haeckel's rule of aromaticity states that for a cyclic planar conjugated system to be aromatic, such a system must have 4n plus 2 pi electrons, where n is an integer. So n can be 0, 1, 2, 3 onwards. So if you take a typical example here, if a compound has 10 pi electrons, for it to obey the Haeckel's rule, we will use this equation, the 4n plus 2 rule. Now, if it has 10 pi electrons, then 4n plus 2 equals 10, and n will be equal to 2. Now, since n is an integer, the compound obeys the Haeckel's rule, and therefore we can classify the compound as an aromatic compound. So, if you use the Haeckel's rule on cyclobutadiene and benzene itself, you can see that, yeah, cyclobutadiene is cyclic, alright, conjugated, and also planar. Its pi electron system does not obey the Haeckel's rule. So in the Haeckel's rule, we have 4n plus 2 equals 4, because there are 4 pi electrons here, 2 here, and 2 there. So it means that following this equation, we will end up having n equals 1 over 2. However, if you look at that of benzene, benzene has 6 pi electrons, 2, 4, and 6. Using this 4n plus 2 pi electron system equation, you will end up having n equals 1 for benzene. Now, since n is an integer, then benzene is to be referred to as an aromatic compound, and cyclobutadiene is not an aromatic compound. So, to sum it all up, we will say that for a compound to be regarded as an aromatic compound, it has to be cyclic, it has to be planar, it has to be conjugated, and it has to obey the Hakel's rule of 4n plus 2 pi electron system. So if a compound is unable to meet all these four criteria, we don't consider the compound as an aromatic compound. So these are other examples for your perusal. So this benzene ring is considered aromatic. This structure is not considered aromatic because it's not cyclic. It's not a cyclic compound. This is cyclic compound. It has 2 pi electron system, 2 here, 2 there. But the nitrogen also has 2 lone pairs of electron. So keep that in mind. So there are 6 pi electrons here. This is also the tropylium cation is also considered as an aromatic ring because it has 2, 4, 6 pi electrons, and it's conjugated because of this cation we have here. And there are other examples as well. You can look at them at your own time. These are other group of compounds you can also have a look at your own convenience.